Good morning. Today I'm going to talk about SUSE Cloud CLM overview. So what is CLM? CLM is an acronym for Cloud Lifecycle Manager. So within Cloud Lifecycle Manager, there are two key components. The first component is a configuration processor. The configuration processor is what takes an input model from a customer based on your servers, your networks, physical infrastructure, and it creates a set of Ansible variables that will end up being used to deploy a cloud. The nice thing about the configuration processor is it's extremely flexible. It allows you to deploy a very big deployment or a very small deployment. In addition, I will talk about some of the playbooks we have that do a complete lifecycle management. So you can stop services, start services, restart services, upgrade services, the whole lifecycle. We'll also talk about some of the other pieces in here, service definitions that come in, and examples. We provide a complete set of examples that customers can use as a template to deploy their cloud. They range from a small cloud to a much larger cloud. In addition, the configuration processor also creates output files before you even deploy your cloud. So the nice thing about this is you see all of your endpoints, all of the host names, everything that will be deployed in your cloud before it actually does it. It allows you to do any pre-work if you need to set up DNS names, any firewall work, any of those type things. And each of these files provides separate information. I won't go into all of them, but for example, address info gives you all of your IP address assignments. So if you're going to deploy in an HA environment, you already know what the VIPs will be. We also have routing info, so all the routes that will be created, server info, how your servers will be allocated, topology information. We also provide a really cool ASCII art representation of the cloud itself that will show you where the services are deployed, whether they're deployed on controllers or computes or things like that. So how do we hook this into Ansible? So as I mentioned, we have these input models. These are things that you set up based on your environment. We provide a large set of examples. We have predefined service definitions that tell us how the services interact to each other. So for example, Nova may consume Cinder, Neutron may consume Nova, Rabbit, any Rabbit connections. And then we have some predefined input files, which are all of your config files. So what does my nova.conf look like? What does my cinder.conf look like? These you can edit. You can change the variables. They support any of the standard upstream variables that are listed for those particular services. All of these get pushed into the config processor, and out comes a set of hosts and group vars for those that are familiar with Ansible. That's what tells us where we deploy services and on what servers, and what types of network connections and ports are in use. And then, as I mentioned, we have a whole set of playbooks here. We have deploy, configure, start, stop, upgrade to do a whole life cycle. And we use this framework here for all of our services. So Cinder looks just like Nova. Neutron looks just like Cinder. So if you're familiar with one set of playbooks, it's all very similar. So it's a very consistent framework. So the key concepts for the input models are services. So we need to know which services. So you're going to run Glance, Neutron, Swift, Barbican, Octavia. So that becomes important. We need to understand the networks. Are you going to have a provider VLANs? Are you going to use external VM and use floating IPs? Are you going to use both? How are you going to handle your management traffic, your public API traffic? All those types of things. What servers have you defined? Will they be computes? Are they controllers? We also have this ability that I'll talk about where you can designate it such that if you have multiple racks of equipment, you could have it pick a controller from each rack. So instead of having all 3 controllers in one rack, you could have it be more diverse. Same with your computes. Also, what type of storage and network interface is on there? Is it local storage? Is it all going to be boot from SAN? And how many network interfaces? Are you going to bond them? Are you going to separate traffic on them? All types of flexibility. And then finally, a control plane, which defines a set of services hosted on that control plane. So for example, are you going to run Manaska? Are you going to have a separate cluster for rabbits? How do you want to do all of that? The main areas of our model, these are the inputs that the customer will provide, are, as I mentioned, which services are included, where do they run, how many regions, how does each service connect to the network, how is traffic routed between the networks, what are the server types, the storage, and physical constraints. And this is what I talked about, the availability. Do you want to spread these out over multiple racks? So we can go something like this, right? A nice, very expanded controller setup, or we can do something much smaller. In this case, we have 3 controllers. You can see what they run here. We have 3 separate nodes for monitoring, metering, and logging, where we run Manaska. We have separate nodes for MariaDB and Rabbit, and then we have our computes. You could also pull Neutron out as well. You could pull Swift out and have several Swift servers. The model is very flexible. It lets you expand your control plane as large as you can imagine, or shrink it down to a minimal set. So the main areas of the model are, we have a cloud, and from there we have what we call a control plane, and I have some animation that will go into all of this. And so we have server roles that configure how the server is going to be used, and each server will belong to a server role. And let me see if the animation is in this slide here. Hang on. Here we are. OK, so we'll go through this one. This is a little easier. So we have a cloud. It consists of 1 or more control planes. A control plane will run 1 or more services. Nova, Neutron, Glance, whatever your flavor of the day is. A control plane uses server role to determine the type of resources it's going to use. And each server has a specific server role. Servers can be put in groups as well. Servers can have different types of network ports. So we use a NIC mapping file, which maps the PCI bus address to a Ethernet name, so that we can map our networks correctly. And then for a server role, there's a specific disk model. So how we use the local storage on that. If it's a controller, you might have more local storage. If it's a compute, you may only have 1 small storage for booting the OS, or you may do boot from SAN. We also have networks, obviously, that are there. We have network groups. Network groups are what determines how the service is handled. So for example, if your network group is the one that's referencing an external API, there's probably a load balancer associated with that network group, and there's probably a certificate so that you can do HTTPS. Network groups can be defined routes to other network groups. So you can set up routes between different network groups. So if you have multiple internal network groups, maybe 1 for your SAN traffic and 1 for management, you can set up routes between them as needed. If I jump back to NIC mapping again, so each server role also has an interface model. That'll define what we do with our network interfaces. Do we bond them? Are they single NICs? How do we spread out all of our different networks? So for example, if you had 10 interfaces on a server, you could bond 2 for your management traffic. You could bond another 2 for external API, another 2 for storage, however you want to do it. And then a network ties into a server group. And finally, a control plane here will use a server group to determine how it allocates its resources. We also have to set up firewall rules. So by default, we block every port except those needed by the services that you've deployed. So if you've deployed MySQL, then we'll make sure that there's an IP table rule for 3306. If you, for example, are not deploying Swift, then those ports won't be open. That's a highlight of what CLM is. If you have any questions, I'll be glad to answer them.